Hey, third grade, today is Thursday, and we are going to start working on something a little bit different. This involves addition, subtraction, multiplication, and division, but we're working on real-world relationship tables. You might hear them called input-output tables, okay? And let me go ahead and kind of show you what they look like. So, here I have a number of hexagons and a number of sides. And then I have the same thing, just in a different direction, okay? So this table goes up and down, okay? It is vertical. And this table is the same thing, and it's just side to side or horizontal, okay? So I want us to look at this. So the number of hexagons is going to determine the number of sides. And the number of sides is based on the number of hexagons, all right? So I want us to look at this. And I'm going to start off with one hexagon. All right. So this is one hexagon. And one hexagon has 1, 2, 3, 4, 5, 6. Has 6 sides. All right. 2 hexagons have 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. All right. 3 hexagons has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 3 hexagons has 18 sides, okay? Now, what if I wanted to find out the total number of sides for 6 hexagons and 7 hexagons, okay? Now, there is a pattern going on in this table, all right? You can kind of think of this as a machine, all right? You put in one hexagon, all right, and out pops 6 sides, because one hexagon only has 6 sides. So what do I do to get from one hexagon to 6 sides? What can you do to get from 1 to 6? Okay, I heard some of you say you can add 5. All right. Now, if I add 5 here, I have to add 5 here, 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 and here to get this answer. All right, sorry. I have to add 5 here and here. All right, so if I'm going to add 5, so 1 plus 5 does equal 6. That works here. But plus 5, 2 plus 5, does that equal 12? No, 2 plus 5 does not equal 12. That equals 7. So this rule cannot work. I do not have a rule of plus 5. Okay, so what else can I do to get from 1 to 6? All right, someone said multiply by 6. 1 times 6 equals 6. 2 times 6 equals 12. 3 times 6 equals 18. So I am going to be multiplying by 6. So 6 times 6 equals 36. 7 times 6 equals, good job, 42. Okay, and if you wanted to check it, you could, if you don't have hexagons at home, you could draw your hexagons. If you wanted to check it, you could draw your hexagons, or we'll just count these because I have some. So 6 hexagons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. That works. That is 36 sides, okay? Now that's 36 if I want to check 7 hexagons. 36, 37, 38, 39, 40, 41, 42. that equals 42 hexagons. So in this table, okay, the number of hexagons times 6 equals the number of sides. Okay? That's going from the input to the output. All right? Now, if you wanted to go from the output to the input, you would just be doing the opposite operation. Okay? So if we're multiplying 1 times 6 here, what is the opposite of multiplying times 6? Good. The opposite is dividing by 6. So 6 divided by 6 equals 1. 12 divided by 6 equals 2. 18 divided by 6 equals 3. 36 divided by 6 equals 6. And 42 divided by 6 equals 7. Okay? So the first way said the number of hexagons times 6, that's the input, equals the output. All right? Now, if I reversed it and I went from output to input, I would say the output divided by 6 equals the input. Or it could say the number of sides divided by 6 equals the number of hexagons. All right? But you can also see this one done, you could have seen this one done like this. Okay? All right? You can also see them done like this. It is the same thing. You're just seeing it horizontal versus this one you're seeing it vertical. And it is important that we recognize that this is the input and this is the output. Okay? All right. Let's look at a different one. And it's important to know that they don't always start with 1. Okay? This one starts with 1 hexagon. I'm going to show you an example of one that doesn't start with 1. Okay, here are my packs of Coca-Cola. That is Mrs. Garza's favorite soda. Okay, so 2 packs of Coca-Cola equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equals 12 cans. All right? Now I'm going to jump. 4 packs of Coca-Cola. I know that 2 is 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 4 packs of soda equals 24 cans. Okay? Here is 24 cans. Oops, you can't see that. There is 24 cans of soda, and I want to do 6. This is 4 packs of soda, and I want to do 6 packs of soda. So I know that 4 is 24. I'm just going to pick up counting there, okay? 1, 2, 3, 4. This is 5. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And 6 packs of soda equals 36. Okay? So, I did not start with 1 here. And then I didn't go to 3. And then I didn't go to 5. I only am doing my even numbers. So if I want to find 10 and 12. I want to find how many packs of soda, how many cans of soda 10 packs has, and how many cans of soda 12 packs has, okay? What do I do to get from 2 to 12? Good. I heard y'all say it. We're going to multiply by 6. All right? 2 times 12 equals, 2 times 6 equals 12. Now, but what if Miss Garza just wanted to add 10? Because 2 plus 10 equals 12. That is a true statement. But 4 plus 10 does not equal 24. So that right there rules that out. Remember, your rule has to work for all of them, not just the first one. Okay? So 2 times 6 equals 12. 4 times 6 equals 24. 6 times 6 equals 36. 10 times 6 equals 60. Good job. And 12 times 6. Ooh, who knows this one? 12 times 6 equals... Good job. 72. Okay? So, and again, you could see this one done this way. 2, 12, 4, 24, 6, 36, 10, 60, 12, 72. Okay? You could see the same thing going on there. That would be times 6, times 6, 6, times 6, times 6. All right? Now, packs of soda would be your input or your output. Good job. Packs of soda would be your input. Number of cans would be your output. Okay? You put in a little machine, you put in 2 packs of soda, and you get 12. You put in 4 packs of soda, and you get 24 cans. You put in 6 packs of soda, and out pops 36 cans, okay? So again, packs of soda is your input. Number of cans is your output. Okay? So the rule for this problem would read, the input times 6 equals the output. All right? And remember, if the input times 6 equals the output times, or the output, what's the opposite to get to the input? The output, good job, divided by 6 equals 2. So you need to recognize the rule both ways. Okay? The output divided by 6 equals the input. Output divided by 6 equals input. The input times 6 equals the output, okay? So it is important that you recognize, it's important that we recognize going from the input to the output and output to the input. Now, not all of your tables, I know that both of those tables were times 6. Not all of your tables are going to be times 6, and not all of them are going to be multiplication. Sometimes they will be addition, okay? Or they'll be subtraction. Now, I do want to point something out. Going from my input to my output, my number got bigger, okay? So there's only 2 operations that you can use to get a bigger number. So going from my input to my output, my number got bigger. If your number gets bigger from going input to output, you're either adding or multiplying, okay? If my number was getting smaller, let's say, or like this one, from my output to my input, my number gets smaller, 12 to 2, 24 to 4, 36 to 6. My number is getting smaller. I'm doing either division or subtraction. Okay, so that is really important to remember. If your number is from one input to output is getting bigger, or whichever way you're going, if your number is getting bigger, you're going to be adding or multiplying. Whichever way you're going, if your number is getting smaller, you're going to be dividing or subtracting. That's just really important to remember. All right, let us know if you guys need any help, and we'll be here for you during office hours.